this lesson, we're looking at factorising non-monic quadratics. So if you remember from last lesson, we talked about what a monic quadratic was, and that was just a quadratic where the a value, the coefficient of the x squared, was 1. Now we're going to go that one step further and look at how do we factorise something that is non-monic. And that kind of looks like some of the harder examples we saw last lesson, but we're going to look at some strategies. So the first step is a bit of a lesson starter. We're going to look at, does the order of process matter? So say we've got the non-monic quadratic 4x squared minus 4x minus 15. If we use grouping, that process that we saw in the previous lesson, we can multiply a by c, which is the 4 and the 15. So this gives us 4 times minus 15, which is minus 60. Then if we look for numbers that multiply to give negative 60, and add to give minus 4, which is the coefficient of x, we'll see what happens. What are the two numbers that will do this? So what two numbers multiply to give negative 60 and add to give negative 4? Now complete the following using the grouping. So we've got 4x squared minus 4x minus 15. We've said, alright, well that is now minus 4x squared minus 10x plus 6x minus 15. So really all we've done is I've split the minus 4x into another expression. I haven't actually changed anything really, because if you think about it, minus 10x plus 6x is still minus 4x. But it relates to what we talked about before. We're using those two factors. So if you notice the pattern we've got here is we started by going, all right, multiply a by c to get negative 60. Now find a sum product rule for 60 to find two factors, and now we're using those two factors as the option to split the 4 into. So that seems a little bit weird, but it will make sense later. It's one way, it's one strategy, one trick that we can use in this process. So then if you complete the following steps, fill that out. Now we're going to change the order. So instead, we wrote it as minus 10x plus 6. So before, we flipped it. So if we look here, we had minus 10x plus 6. Now we're writing plus 6 minus 10x. See what happens now when you solve it. The learning intention for today is really to understand the relationship between expansion and factorization for a binomial product. We also want you to be able to know how to apply some of the different processes we're using for factorizing a non-monic quadratic trinomial. There are actually a few different ways to do this. If you've heard of a method before, there are others. One method, which is referred to as the cross method, is sort of shown below. It starts by using a list of factors for a and c, and then they use that to find a correct combination. So for example, if we had the 4x squared minus 4x minus 15, we're looking at factors of 4 on this side and factors of 15 on this side, and we're then kind of following that process to go, all right, what did we find? What's common? We've got a 2x plus 3, 2x minus 5. That's one way you can do it. It can be a little bit clunky. We aren't going to cover this method. We're going to use the grouping method that we've seen in the previous lesson. We're just going to take it a step further. But just be aware there are other methods. If you're kind of looking at this and trying to follow the steps and it doesn't make sense, that's okay. As I said, we're not going to use it. I think this method is much slower and a little bit clunkier to use than what we're going to use. So key ideas. If you're going to factorize a non-monic trinomial, it's a mouthful. Trinomial, 3 sets of things, 3 terms. Non-monic, a is not 1. These are the steps. First, find two numbers that multiply to give a times c and add to give b. So two numbers that give you a times c. So we could say step 1, a times c. Step 2 is two numbers that multiply to give AC, whatever that is, and add to give us B. That's our next step. So, look at an example. 15x squared minus x minus 6. A times c is the 15 times minus 6, which is minus 90. So we go, all right, what numbers are there that add to give -1, which is the b? So remember, b is up here. So -1 is here. They are -10 and 9. We then use the two numbers in the example. So we've now got those factors. We've got 10 and -9. You use them to split the x, the bx term, just like we saw in the previous example. So you can see over here, we've split it. We started with -1x. We've rewritten that as -10x plus 9x, which is still -1x. So if we weren't actually leading to something, this would be a really useless step. We've just made an equation bigger and look more complex than it needed to be. However, it has a purpose. So then we factorized using the grouping. So now we can go, all right, I can pull out a 5 and in fact an x from the first piece. So I go, I'm going to group this and I'm going to group this because I can see common factors here. I can see common factors here. So I pull out the 5x, I get 3x plus 2. I pull out a 3, I get a 3x minus 2. And then we use that rule. Remember, we've got 3x minus 2, 3x minus 2. So that's going to be in a set of brackets. And then 5x plus 3 becomes the other brackets. And then we're done. So that is how we're solving a non-monic trinomial function, or basically a non-monic quadratic equation. To start off with, get some practice of that a times c concept and multiplying numbers. I want you to fill in this table and then factorize these by, in fact, actually, let's leave this. Don't do these ones because there are no solutions provided. You'll get plenty of practice in the next slide. But fill in the table. So start by going, all right, what is the a times c? And then what two numbers give a times c, but also add to give the b? So a times c, add to give b. So fill this out. Double check your answers because you can always just check. Do my factors make sense? Does -8 times that give me what I want? Does -8 plus that give me what I want? Etc. So have a go at that. To show you some more worked examples. So if you're still sort of struggling with the concept, you want to see a few more examples of some processes. Here's an example of the factorization process. So again, you can see they've started with the 19, they split it, so they've identified the factors using that sum product rule. They've split it, they've grouped, what have we grouped? These ones and these ones. So where that started is once they've split, they've said, cool, I can see, what did we pull out? We pulled out a 3. So 3 is a common factor, 2 is a common factor. And then I've got my groups, these are the same. 3x plus 2 is going to be my second bracket. What's in the brackets becomes the other bracket. So that's that process. Let's get some practice. So we'll start off with, let's just do A. So that's I and II, or A1 and A2 for Roman numerals. And then for the following, what are we looking at? We're just looking at more and more sort of complex variable numbers. So let's go with column 1, column 2, column 3. And in all of these examples, as I said, in fact, let's set the challenge. If you get one wrong, you have to add one. So if you get A wrong, you do B. If you get M wrong, you do N. So that's the goal of you work across. If you make a mistake, you have to do the one that's parallel to it. Same for this one. You jump across, you need to do this one. For C, just work backwards. If you make a mistake in C, you'll end up doing B there. Once you've done those questions here, we're now looking at a similar concept. So we're now just simplifying by first factorizing. So in this case, let's just do the first row. So have a go at those, simplify by factorizing, and then now we've got a great worded question. So we're applying this concept. We want to factorize, determine the height of the cable when x equals 3. So that's some good substitution stuff, links to what we talked about last topic. And then determine where the cable is at the level of the water surface. So think about what that means mathematically. So have a go at those. Answers are on the right hand side if you want to check. If you get stuck, obviously feel free to speak to your team, ask me, etc. But that is the end of today's lesson.